In this video, we will provide information for getting started with the CEM102 EVB. We'll cover what software you need, setting up the CEM102 EVB, importing, building, and debugging your first application with the onsemi IDE and RSL15, and finally, how to monitor current value using TerraTerm software. To get started, you'll need the following required hardware: CEM102 Evaluation Board, J-Link Pro or J-Link Plus as JTAG adapters, and a 9-pin adapter cable and connector for J-Link. You'll also need a PC with USB ports and a power source for the CEM102 EVB. If UART monitoring is needed, please prepare an FT2232H module. Let's start by connecting the J-Link to the J-Link adapter. Then connect the J-Link adapter into the J4 board terminal. Next, connect the FT2232H module into the J3 board terminal. Now let's move to powering the CEM102 EVB. The CEM102 EVB can be powered in two ways. The first is to use a coin battery in the battery socket on the back of the board. The second is to use an external power supply connected to the VBAT and ground terminals of the J5 board terminal. Please don't connect both a battery and external power supply to VBAT simultaneously. It can cause damage to the board or the power source. The CEM102 EVB supports voltages of 1.65 volt and lower out of the box. It can support voltages higher than 1.65 volt, but it requires you to change the board assembly. After powering the CEM102 EVB, you can check the J-Link interface by using the J-Link Commander reports. You can find it under the Windows menu on your PC, then in CGAR J-Link version. Now let's move on to setting up and navigating the Eclipse-based onsemi integrated development environment called onsemi IDE. This environment is essential for effectively working with onsemi devices like the CEM102 and RSL15. To download the onsemi IDE, go to the RSL15 product page, onsemi.com/RSL15. Then download the onsemi IDE installer and RSL15 firmware package. You will need to register for a MyOn account before downloading if you don't have one. After downloading the onsemi IDE installer and RSL15 firmware package, go to the CEM102 product page, onsemi.com/CEM102. Then navigate to the Design Tools tab and download CEM102 firmware package. Now let's install the downloaded onsemi IDE on your PC. It comes bundled with the CGAR J-Link installer. Please note that J-Link version 7.60 or higher is required for CEM102. Next, open the onsemi IDE by selecting it in the Windows Start menu. To ensure compatibility, it is important to create a new workspace for each new version of the IDE. On the top right corner of the Workbench perspective, click on the Open Perspective icon. Select CM/Sys Pack Manager and click Open. Now click on the Import Existing Packs icon. Open your download onsemi conductor RSL15 version pack in the RSL15 firmware package. You can see the download status on the bottom right corner of the Workbench perspective. When the installation is completed, a message appears on the console. Next, you will also need to import onsemi conductor CEM102 version pack in CEM102 firmware package. The appropriate CM/Sys pack now appears in the list of installed packs. If the packs do not appear, click the Reload Packs in the CM/Sys pack root folder icon. Now let's walk through the process of building and debugging your first application using the onsemi IDE. First, you will need to import the sample application code. In the Pack Manager perspective, click on the Example tab to list all the example projects for the RSL15 device. Then click on the Boards tab and click CEM102 Evaluation. Choose your example project called CEM102 Basic and click Copy to import it into your workspace. The CC++ perspective will open and display your newly copied project. In the Project Explore panel, you can expand your project folder and explore the files inside your project. On the right side, the CEM102 basic.rte config file displays software components. If you expand the device drop-down menu, you can see the selected components for CEM102 Basic. Next, let's build the sample code. Right-click on the folder CEM102 Basic and click Build Project. Alternatively, you can select the project and click the Build Project icon. That looks like a hammer. When the build is running, the output of the build is shown in the CC++ Development Tooling CDT Build console. The key resulting output can be seen in the Debug folder or Release folder in the Project Explorer. There are several types of files you will see here. Hex files are for loading into flash memory. ELF files are ARM executable files run from RAM and used for debugging. And map files show sections and memory usage. Now right-click the CEM102 Basic in Project Explorer and select Build Configurations. If needed, you can change the target folder by clicking Set Active. Now let's debug the sample code. Right-click on the CEM102 basic.elf file in Debug folder and select Debug As, Debug Configurations. When the Debug Configurations dialog appears, right-click on GDB CGAR, JLink Debugging, and select New Configuration. A new configuration for CEM102 Basic appears under the GDB CGAR heading, with the new configuration details in the right side panel. Navigate to the Debugger tab and enter RSL15 in the device name field. Ensure that SWD is selected as the target interface. Make certain that the Other Options field in the JLink GDB Server Setup section does not include the No GUI option. Now click the Startup tab. Ensure the Initial Reset and Halt checkbox is unchecked. Once the configuration changes are applied, make sure that the EVB is connected to the PC and click Debug. JLink automatically downloads the CEM102 Basic sample code to RSL15's flash memory. The debug perspective opens, and the application runs up to the first breakpoint. Press F8 or click the Resume icon to resume the execution of the application. Now let's review a methodology to measure current values at the WE1 channel using the CEM102 Basic application. We use the TerraTerm software for monitoring the values. Please note the location of the WE1 and ground pins used for measuring and monitoring current values. Open the TerraTerm application and select the serial port to use and click OK. Ensure the selected port is your connected USB port and the speed is 115,200. Then click on the OK or New Setting. Now navigate back to the onsemi IDE software and click Resume or F8. Calibration is crucial to ensure the accuracy of your measurements. You can monitor the messages in the TerraTerm application. Calibration is complete when you see the message, Measurement has been configured, enabling measurements. If the application is working correctly, you can expect to see formatted measurement values printed to the UART every 2 seconds. You can examine the accuracy of current measurement at WE1 by inserting a resistor between WE1 and ground. In this case, the resistor is set to 1 megaohm between WE1 and ground. The CEM102 Basic sets the WE1 voltage to approximately 499.2 millivolts. You can confirm calibration is complete by checking that the WE1 voltage value, typically around 500 millivolts by default, has stabilized. Measure with WE1, either in an open state or with a sufficiently high resistance such as 10 megaohm between WE1 and ground. Label this value as actual WE1 volts. Next, measure the accurate resistance value of the resistor to be inserted between WE1 and ground. Label this as actual R, ohm. As a result, the theoretical current value at WE1, 1 cal, can be determined by this equation. Now, if you navigate back to the teraterm application, it shows approximately 499.5 nanoampere. This unit is measured in femtoampere. As you can see, the CEM102 is highly precise, and it can measure impedance of sensor or current in this way. You can also take other various measurements by changing the firmware. Contact us if you have additional questions about getting started with CEM102 EVB.